Okay, let's get going on this. This is video 91, and purpose of this video, it's very important that you pay attention to it, is to advance our ideas, like I mentioned this morning in the letter to you guys, by getting a little more abstract, and then we're going to apply these new ideas to calculating squares of things, okay? So let's see how it goes here. Let A be a variable and let B be a variable where A is not the same as B. That's completely reasonable. Okay? And I have A plus B squared. And in this case, the A variable is 3x. In this case, the variable is 2. I just FOIL them, come up with the pattern. I'll show it to you in a second. Or another example where we're just looking at the same idea, A minus B squared will let A be 3x, and in this case B is minus 2, and we have the same idea. So let me work that out, and you'll see that we've done this before as I do this here, and the purpose will be here in a couple of minutes to calculate 27 squared, and then I'll do a couple of other ones. So let's take a look at A plus B squared. There's A plus B squared. Get over here so you can see it clearly. Obviously that means A plus B. And again, I want to repeat, A and B are any variables, anything that's distinguishable. We gave you an example here. We're going to substitute A and B with numbers in a second, times A plus B. Okay, I FOIL now, and I get A squared. And now I'm going to do the B squares. So I'm doing F squared and then L squared, like I did before, because it's easier to calculate that set. And then I get 2AB. Where did I get 2AB? AB plus BA. And you remember quickly that AB equals, BA equals AB by definition. Just like 2 times 3 equals 3 times 2. So I have that there. In fact, I'll fix it up just a tiny bit so you can see what I'm trying to say. Make sure there's no real confusion here. That I had AB plus BA, and that equals 2AB because AB and BA are the same numbers by the commutative property of multiplication, if you need justification there. And then underneath, we'll do A minus B, and we've certainly seen this before, and so I write that out, and I get A minus B. That means times A minus B, and that again is A squared plus B squared, and this is 2OI, as we know before, minus, as we discussed with you before, okay? There you go, okay? And so this would be here minus 2AB, as we explained to you just in the previous problem. So let's take a look at this. We got it all down here. We have A squared, A plus B squared. We have A minus B squared. We have them written out abstractly, and we see what happened here. There's your plus. There's your F squared here. There's your L squared here. And there's your minus 2AB. And there we go, and each time we do it, we get a quadratic trinomial, 3 terms, the largest degree being 2, and then we're looking like we're sitting pretty here, and we want to keep this in mind. These are in all the textbooks. And now I'm going to erase down here and give you an application of this, and we'll probably stress this a little bit as we go along, because the Regent certainly does. And now I'll, as I erase this and dry it off under here, I'm going to use a new way to calculate 27 squared. Now, the easiest way to do it, of course, is a calculator. I think everybody understands that. But there's other ways to calculate it besides writing 27 times 27. And I'm going to use FOIL, this new method that we're talking about, or this method that we're talking about, and I'm going to rewrite 27 squared like that. So you might say to me, well, what are you doing? Why are you doing that? Well, I happen to know what 20 squared is, and I happen to know what 7 squared is. So if I know these, I can just FOIL the numbers. And I get 20 plus 7 times 20 plus 7. And when I put them together, 20 times 20, as we know, is 400. 7 times 7 is 49. And now it's 20 and 7, and I multiply it by 2. So that means it's 449 plus 140 times 2, which is 280. And there's the correct answer, 729. Okay? So I'm going to ask you to do a couple of these kind of problems. I'm leaving it out so you can look at it a little more carefully. And like I said, you might say, well, why didn't you use 25 plus 2? Well, the answer to that is I know 20 squared much better than I know 25 squared. But it works. If you know your perfect squares very well, you can do a problem like this. Let's try another one. The same number, I mentioned both ways, and let's get the same answer subtracting this time. So what's another way to write 27 squared using subtraction? Well, I would say 30 minus 3 is equivalent to 27 squared. So I'll just write that out, and that means I get, using the FOIL method, I get 30 minus 3 times 30 minus 3. And when I put that all together, I get 900 plus 9. Again, I'm just following the tracks of the math that I did before. Plus, minus now, because the second term is negative here, minus 2 times 3, 30 times 3. And so when I put that all together, I get 909, and then 30 times 3 is 90, minus 180, and there's 9, and then we'll just borrow from our neighbors here. We won't bother with a calculator. And there you get the same answer all over again, 729. So all Regents classes ask you to do simple problems like this. They're asking you to calculate square of a number. You come up now, we know that, for example, that 729 is a perfect square. We can do this with any number we want, as long as we break it up properly in an interesting way. I'll do it again for another number, and I'll just leave it open for you just for a second so you can try to figure out what's going on. Here we are, cleaning up a little bit here, and I'll write out the number, and let's see if we can figure out what 62 squared is, okay? And again, I'll do it both ways, and you can check me on a calculator anytime you want. And let's break that out and use our a plus b squared format to do this. And here we go. Obviously, I'm going to use 60 plus 2 squared, which equals 60 plus 2 times 60 plus 2. And then let's make sure we're okay here. All right. Okay. And then we go over here, and 60 times 60, that's why we're doing all this, is 3,600. We all agree to that. And then 2 times 2 is 4. And as we move along here, we write 2 times 60 times 2. We add everything together, and we get 3,604. And then 60 times 2 plus 240. And you can check me if you like on the calculator. And that's kind of interesting. The 3844 is a perfect square. And when I put the hat on it, it comes out to 62. Kind of interesting to be able to do that. I'll do it the other way as well. And I'll have to do it 70 minus 8 would be the easiest way to do it the second way. I'll erase this. And even though it's a little bit more work than 60 plus 2, it still works. here to show you how these ideas work right off the Regents book. And I'll give you some as an assignment after I finish doing this and the assignment number 35. So now we'll say 62 squared equals 70 minus 8 squared, right? Making sense? We'll move this over a little bit here, okay? And then again, you can figure this out on your own. That would be 70 minus 8 times 70 minus 8, and we'd end up with 4,900 plus 64, and we'll add those together, 4,964, and then we'll subtract 2 times 7 times 8, and let's see what we get, 560, and 560 times 2, you know, and it's always more work when the numbers are bigger. There's a 0, and there's a 12, carry the 1, so minus 1120. And then again, if you notice, we're coming up with the same answers, square root of which is 62. So that was what we wanted to get going for you today. I'll give you a couple things that you can get doing. And I also want to point out to you that we will have one more configuration that we want to look at that I deliberately haven't mentioned yet for you. And with that, we'll be able to do some homework. So we'll be able to work on these. I always get the protest, well, why would I want to do this if a calculator can do it, or I can multiply 62 times 62? The point of doing math is to look at things in different ways. And we're using FOIL to calculate perfect squares as numbers in this particular case, a direct application. And again, it would work if you go back and you turn your attention to where I started the lecture. If I plugged in a number here, we'd be, say 2. 3 times 2 plus 8, we'd just be calculating 8 squared. And if I plugged in the 2, it'd be 6 plus 2 times 6 plus 2. We'd add them up using FOIL and you'd get the answer. So there we go. I want you to keep this in mind, and the math that we broke down together, an important video to watch. So let's put this,